Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 59, we will talk about mode choice models using machine learning. So, the different concepts that we will cover, we will introduce machine learning first, and then machine learning algorithms used in mode choice, and then we will look into the decision tree and decision tree, different types of decision tree, the mode choice model using decision tree and Python. We will also look into random forest decision tree, and then finally, we will do mode choice model using random forest decision tree and Python. So, basically in our last lecture we have ended with activity based models, where we have discussed that one of the popular models, Albatross, it uses decision trees to determine the different choices or the different steps in the model. So, any kind of choices could be modeled through decision trees. So, in this particular lecture we will be focusing on mode choice. So, what we are seeing gradually in the overall urban planning, that travel behavior modeling for heterogeneous population, and particularly case of India, it is becoming very complex and challenging. So, there is lot of data is involved, lot of relationships are there which needs to be found out. So, this is one area which requires us to look into a little bit into different kinds of model systems which are easier to build compared to this the choice models that we have built earlier. Then there are a lot of the performance of traditional methods which data associated with uncertainties and complex systems are also poor. So, this is another reason why we should look into other techniques. And Government of India has taken a lot of initiatives and lot of ICTs, internet and communication technologies are being adopted for our urban areas. Our cities are becoming smart. So, there is a lot of ITS systems, intelligent transportation systems, which are collecting data every day, like locations of buses at different times of the day, and it could also tell us about speed along a particular corridor. So, all this lots and lots of data is being collected, and this we also know them as big data sets. There is also mobile based data on transportation services, open source databases, web services, and so many other things. So, there is a chance to introduce a new kind of analysis technique, which is artificial intelligence in travel demand assessment particularly. And the reason is these are cost effective, these are data mining techniques. Of course, we can work with a huge amount of data, we can find trend patterns among those data, and this could be done in a very cost effective manner, and it is reliable, it is quantitative, both for quantitative and qualitative data, and it is also good for data with uncertainties and probabilities. So, that is why these are the reasons why increasingly AI being used in many of the models that are being developed, and many of this kind of processes are actually being represented using AI algorithms. So, let us see what AI algorithms actually mean, or how do we develop this artificial intelligence models. So, AI or machine learning algorithms, we use the term machine learning algorithms, and there has been examples of many researchers using machine learning algorithms for mode choice, and these methods are an alternative to the existing statistical approaches, particularly multinomial logic choice and for modeling travel mode choice. And these models can determine and present complex relationships from data without making strict assumptions about it. Like in MNL model, we had a assumption. If you remember the MNL model, it was an assumption for Gumbel. We assumed that the data was, this error was distributed following Gumbel distribution. It could also be assumed to be normal distribution. So, these assumptions are there. So, then it would have been a probit model. But if we can avoid these assumptions, then we can develop even more robust models. So, this AI machine learning algorithms actually are not limited by these assumptions first of all, and second of all, it can also present very complex relationship and can summarize those or show those patterns and trends, and that is why these machine learning algorithms are becoming popular. So, one of the very popular machine learning algorithms, probably all of you have heard that, artificial neural networks. So, what is an artificial neural network? So, it sounds scary, but actually artificial neural network are artificial neurons, which is again like sort of a decision box. That means, if input goes into that, it gives an output. So, this is just a decision window. That means, if I get a input based on my examples that I can see from data, what happened, I will also do some prediction of something. So, that is what an artificial neuron, what it does. And it has also got, and then there is not one artificial neuron, there are many of these decision windows, and these are all connected, and these are directed. That means, if I can say that this is one decision, it is connected with another decision and so on. So, we can have many decisions like that, and it could be connected, and from there you can again have another set of decisions. So, this is we use artificial neurons and directed connections. So, there is also direction. That means, if there is an input, then based on this neurons, that is how this neuron has been trained using previous data, in which direction it went, and then what was the output, and this could be also coming from different attributes or parameters and so on. So, and then this output also depends on certain weights that has to be given. So, this is how our artificial neural network works. It is similar to, like, we have got this predictor variables, like exploratory variables, and this is the output, which is the independent variable. The dependent variable, and these are the independent variables, and in between we give weightages to determine how much each one of that contributes and how it contributes. So, the same thing is also done in artificial neural networks. So, the model is trained using data with both independent variables and the outcome, which is the dependent variable, to determine the weights of these connections while being processed by the neurons in the hidden layer. So, there is an input layer, then there is a hidden layer. This hidden layer and then there is the output layer. So, this hidden layer is the number of neurons in the input layer equals the number of input variables, and the number of neurons in the output layer equals the number of outputs. So, this is the mode choice. Maybe there are 3 mode choices, and input variables may be income, then ownership of existing vehicles, or the travel cost. All these things could be input variables, same as we have done our MNL models. So, number of neurons in the hidden layer, that means this process is a little bit abstract, we call them black box model, but it is like this number of neurons or the number of layers in it depends on number of decision boundaries we need to draw between the different classes or categories that need to be predicted. So, if I got different data points, so this is car, this is bus, this is again car, this is again bus, this is car, this is bus, this is bus. So, if I draw a line over there, so this actually separates cars and buses. So, this line could be drawn in different planes in different ways and so on. So, this hidden layer or these neurons are actually helping us to create this decision planes, using which we can separate the different classes. So, that is how this artificial neural networks work. So, this is one kind of machine learning algorithm that could be used to also categorize data. So, similar to artificial neural networks, we also have some decision trees or classification trees, we call them both, and these are this uses a tree like data structure for classification, and the nodes of the tree represent binary decision rules, edges the answers to the question, and leaves represent the classes. So, these are the leaves, these are the final results, like here we have a mode choice question, there are 3 classes, the classes means the outputs. This is either bus, auto rickshaw or car. So, these are the three options, and then we have got decision windows. So, we start with the root node. Root node is the first decision window. So, it is about car ownership. So, does he have a vehicle or does he have less than 2 vehicles? So, does he if he does not have a vehicle and if he have less than 2 vehicles. So, these are the decision point. So, these are the points where we can say if it is yes, then if it does not have no vehicles, in that case they will either use bus or auto. If there is vehicles which are lesser than 2, that means they can have at least 1 vehicle. Some of them may have use a car, but others will again use bus and auto. So, there what we are doing is we are dividing our entire data set, taking certain decisions, certain attributes we are bringing in, and we are asking questions on those attributes, and based on the questions we are separating the data into different groups. So, the decision trees are nonlinear decision making with simple linear decision surfaces. So, using this we can use these are basically we can solve nonlinear situations as well. It solves nonlinear decisions, but we use linear decision surfaces, or those planes that we are talking about, those were linear. So, this decision trees are predictive models constructed using algorithms which splits the data set based on different conditions. So, these different conditions are the decision rules, which is done by if then else statement. If this is there, yes or no, and then else this happens. So, that is what is happening over there. Car ownership, if it is no vehicle, then or if it is else it is lesser than 2 vehicles, then what are the options. So, this is how we are splitting the data, and it is a non-parametric supervised learning method. It is a learning method, means first we have to train the algorithm to based on the data set, that what are the results it is getting, and accordingly it will select that what are the questions that needs to be asked to segregate the data, so that we can arrive at those results very fast. So, what questions to be asked at each step, so that we can arrive at the final classes or so that we can do the predictions properly. So, that we have a tuple. A tuple is basically suppose a prediction, like a person uses a car. Now, we have got his income, we have also known his vehicle ownership, we also known some other parameters. So, now I have to I get a particular data set, I need to ask that data that is your income higher than a certain value or lower than a certain value, or then based on that I will ask him another question like, okay, if your income is higher, then do you own a car or not, and based on that we can predict what is going to be his ultimate mode choice. So, this kind of questions could be asked, but decision trees gives us the sequence in which we have to ask these questions. So, we have got a root node in a decision tree, the first node, that means which question we should start with, and represents the entire population sample from where the first splitting starts. A decision node is all the subsequent points where we ask further questions, or that means intermediate nodes where further splitting is possible. That means we can keep on splitting the data, sometimes we can also over split. That means we also need to be careful that we do not also subcategorize. So, if we subcategorize, then the model becomes complex. So, splitting is dividing the root node and the decision node into further decision nodes or leaf nodes based on decision rules. So, this is the basic structure of a decision tree. Now, there are some techniques in machine learning which are called ensemble techniques, where we combine different techniques, and because we are combining different techniques, we can gain the strength of each one of these techniques. So, decision tree based ensemble techniques, these are some of them, like there is something called a boost tree. This technique is basically boosting, where decision trees are built in sequence and successive tree attempts to correct wrong classification. So, we once build a tree, then we build another tree, then we build another tree. So, the successive tree attempts to correct wrong specifications which were classifications which were done by the previous tree, and finally, a weighted voting among all trees is taken to get the final result. Then we have bagging, or this in this process decision trees are trained in parallel using sample data. Sample data is generated by bootstrapping. Bootstrapping is a method where from little bit of samples we can create many samples following some distributions, and decision trees are trained on this particular data, and in parallel many decision trees are done, and majority voting among all the trees are taken as the which class this particular data or tuple belongs to. So, based on that we will take the decision. Random forest is almost similar. There also we are decision trees are trained in parallel using sample data developed generated using bootstrapping method, and it splits at the node. That means the divisions are determined by random subset of variables. So, we create different trees and we select that split instead of following there are certain rules how we select the decision node, how to split the data and so on. So, here it is done randomly, and majority voting on all trees is done for class assignment. So, because we are taking the feedback from many trees, so of course, the result improves compared to a normal decision tree. So, we have seen that in many examples, random forest decision trees have performed very well in case of mode choice model. So, now to summarize some of the mode choice models that we have found in literature where machine learning has been used, and we found that decision trees have been used. So, decision trees are white box models, you can exactly see what questions have been asked, what is going on. It is a supervised classification approach, that means we have to first train the model with the existing data, and then it can using that data set it can do the predictions. But if it gets a situation where it does not know what to do because it has not been trained in that kind of a situation, then it would not be able to predict. Then there is chances of overfitting of the data, this is one problem, and error due to bias and variance may be present in a decision tree. Then there are neural networks we have discussed ANN. So, these are black box model, difficult to interpret the results. So, this is where it is very difficult to say what is the steps, how the decision has been arrived at, but again this works pretty fine when we are only concerned about the final outcome. So, fuzzy model is good at dealing with vague or linguistic expressions and so on. So, there is lack of learning ability in this kind of model. And then we have hybrid models like the neuro-fuzzy model, where ANN and this fuzzy techniques are being integrated and they complement each other. And then we have the random forest decision tree, where we can reduce the error in decision tree model due to bias and variance by increasing the number of trees that we actually are looking at. That is why the bias and variance would be reduced. And we also have something called support vector machine. This is again a very advanced technique. This is again here different decision planes are created for the same set of data, and using that different decision planes we can do better classifications. So, this is again a supervised learning model for classification and regression. So, these are the different machine learning techniques which we find has been used in previous research for mode choice models. Now, when we start making a decision tree, one of the first thing is to determine what should be the root value. That means, how do we arrive at that question, what has to be asked, so that the decision tree is split in the proper way. And not only the root value, subsequently whenever if we ignore the top root, then again the decision node becomes the root. So, for that particular subset of data. So, there again what we should ask questions. So, there has to be a strategy to that. So, this is the first thing that needs to be known, and then complex decision trees can be simplified by pruning subtrees at selected leaf nodes, and this increases quality of the classification model. So, too much classification into these branches, that is also not good. So, that means some amount of pruning techniques are also followed. So, there are three ways we can prune. One is pre-pruning, where a decision tree involves using a termination condition. Pre-pruning a decision tree involves using a termination condition to decide when it is desirable to terminate some of the branches prematurely as the tree is generated. That means, while the tree is being generated, some branches we do not go further, of course, based on some criteria. Then in post pruning, decision tree is generated first, and then non-significant branches are removed. And finally, in pessimistic pruning, a sequence of trees are built by removing one rule in each step, and lowest error among and we will remove those where there is lowest error among all the possible removals. We will remove that which shows the lowest error, and this result in the smallest tree with lowest error. So, this is the three ways we can prune a tree, but before pruning, of course, we have to also look into how we determine the root value, because not all decision trees does pruning, only some decision trees does pruning. So, just know that pruning is also possible. So, when we are developing a decision tree, so we first have to decide on what should be the decision point from where we should start. So, for that we have to calculate the entropy. So, entropy is basically how when we split the data using any decision point or at a decision node or at the root node, what is the amount of randomness in the sample after the split. So, the randomness could be measured using a value of 0 to 1. Had the value of entropy, had is the randomness, there we can see. So, this entropy value could be 0 to 1, whereas this probability at entropy 0.5 at entropy equal to 1, that is we will have 0.5. That means, there is a maximum mix, that is 50% of one group, 50% of another group. So, this is that is why it is a 0.5 probability. So, when it is entropy is lower, then the probability is also lower. So, what it means is, in some of the splits there could be more randomness, in the other there could be less randomness. So, randomness means there is mixture of different outcomes. So, to calculate entropy, where entropy for a particular set E s is given as negative of summation I equal to 1 to m pi log of to the base 2 of pi. So, this is the formula for calculating entropy, where pi is for given for this is C, we have seen C I and D and then divided by D. So, this is how we estimate the probability, that is out of D the training set, D is the training set of class level tuples, which is row of a data set, and C I is the class level attribute has m distinct values for I equal to 1 to m. So, C I is one of the splits, and then so that means that we find the probability of that outcome within that particular data set, and this CID is the set of tuples of class Ci in D, and D and CID denote that number of tuples in D and CID. So, D includes all the tuples, CID includes only those tuples where it belongs to Ci, and CID is the set of tuples of class Ci in D. So, tuple is basically, I have already explained, tuple is all the attributes, like it is a row of data. So, there is an outcome and then there are attributes to that particular outcome. And then this using this we can determine the probability of this CID divided by this D, this gives us the probability, and this we can also call as sort of information. So, one is information of D, and in the next step we will determine what is the gain in information. So, first we determine what is the total entropy that is being there for this particular split. So, in the next step, when we are calculating the information gain, what it means is we will select the parameter which has got the biggest value of information gain and that we can select as the root node. And once that is done, in the next step, whatever is that split and whatever data we have got in that split, we will again use another parameter and that becomes my root node for that particular subgroup, and using that we can also keep on doing that and iteratively, and this process is iterated by excluding the newly assigned root nodes at each step until last bottom leaf parameter becomes the target value. So, we estimate the total amount of information that is gained, and so info AD, which basically means the gain of a interested element A is calculated by interested element A means the candidate for splitting the particular decision tree. So, we can use either any parameter, like when we have a tuple which we have got mode choice as the final outcome, and then in that this characteristics are like income, car ownership. Which one we should start with? Should we use income to first split the data set, then we use car ownership, or we should start with car ownership and then go to income. So, we find which one will give us the more information gain. So, should I use information gain, should I use car ownership or this income to split the data. So, when we use income, which is the interested element A, we have to calculate the total amount of information gain, which is info D, that is information or entropy of D, minus info when we use A. That means, without using A and then using A, what kind of entropy is there, and the difference between them gives us the entropy gain. So, that means the information gain. And so, info A D denotes the entropy of A, where A is the element of D training set, and dj divided by D the weight of the jth partition. And because we see, whenever we are splitting the data, so using this A, that means there could be 3 classes of A. So, these classes are j equal j to V. So, j equal to 1 to V are the different classes. Each class will have different 3 splits. So, income are 3 categories suppose. So, we will divide the data into 3 different groups. So, each group has a mixture of positives and negatives, that means the correctly predicted data and not. And then for each of this split, we will have information, we can calculate the information gain. We will multiply with the probability of that particular number of observations in that particular split divided by total number of training data. So, using this is the probability of that group into the information group for that group. So, we sum it up for the entire this A characteristics. So, this is how we can calculate the information gain, and once we calculate the information gain, the parameter which shows the highest information gain will be used to split the data. So, for that particular data set. So, this is how we do that. So, instead of doing determining information gain, we can also use the parameter gain ratio. So, gain ratio is used also for partitioning in practical applications. The attribute with the maximum gain ratio is selected as the splitting attribute, and calculation of gain ratio is gain A divided by split info A, and split info A is calculated using this particular formula. So, we have already said J A to V are the different classes. And based on that we have done the splits, and then this dj divided by D is the proportion of that particular split data set, and multiplied by log of to the base 2 the same proportion. So, this is the gain ratio. So, we can also use along with entropy, we can also use something called Gini impurity. This is a similar kind of measure which measures the impurity in the classified outcome like entropy. And Gini index calculation could be like Ig is equal to 1 minus summation j equal to I to C of Pj square. So, again this is j to C are the different classes. So, Pj is the proportion of samples that belongs to class C for a particular node. So, this is an easier way to calculate. So, both entropy calculation and Gini impurity help to determine a good split point for root decision nodes on classification regression trees. So, these are the final outcome. This is the final mode choice maybe. So, over here there is a few of this is card, this is card, this is bus maybe, and over here there is bus and card, this is mixed. So, if I split using this particular line, that means a particular decision plane or decision window, then we find on this side there is low impurity and this side there is high impurity. So, there the information gain would be higher. So, this is what we have to calculate. So, overall when we do this, overall information gain is both gain over here plus gain over here multiplied with the proportion of data points that are there. So, in that way we can calculate the overall information gain. This is what is used to decide on what parameters should be used to split the tree, and which parameter should be at the beginning of the split and which parameter should come subsequently. So, decision tree are of different types. Top down decision tree inducers or algorithms. There is the ID3 algorithm which was introduced by Quinlan in 1986. then C4.5 algorithm, which is for again by Quinlan in 1993. Then the CART algorithm was also introduced in 1984 by Brayman. And C4.5 and CART consist of both growing and pruning phases, unlike other algorithms which can perform only the growing phase. So, first we build the tree, but we do not prune it, but C4.5 and CART do prune the trees. So, when we create a decision tree, it could be entropy based algorithms like ID3 and C4.5. These are entropy based algorithms. We can also build it based on Tweng and Gini algorithms. This, like the one that we just discussed, we can use the Gini coefficient. Then we can use Bayesian classification, or we can also have rule based classification. That means, based on certain decision rules, we can also take certain, we can also divide the tree. So, these are the different ways decision trees could be built. So, let us see an example of mode choice model using decision tree, and we will use Python. Mode choice model for workers is being developed. Two parameters are selected: monthly household income level and car ownership. Income level is divided into three categories: higher, middle and lower. So, lower is less than 20,000, 20 to 50,000 is middle, and higher is greater than 50,000. And number of car ownership is 0 in case no vehicle ownership, and else the number of vehicles owned is mentioned. So, available modes are car, bus and auto. Auto means auto rickshaw. So, 70% data is used for training and 30% is used for testing. So, in any kind of supervised learning algorithms, we have to use some of the data to first train the model. Using that, all the decision window decision criteria would be created, and after that we have to use the model to test that if my model is performing properly. And then there has to be some testing criteria as well, validation criteria as well, if the model is giving us good result. For example, we can also use a confusion matrix to determine what is the final outcome. Is the model predicting correctly or not? So, we have used the CART algorithm. It is part. That is what is available in Python. We have used Python 3.8.7, and we have used the Jupyter notebook like earlier that we have used when we have used Python. So, this is the hypothetical data set that has been generated. Number of cars owned are given over here. Monthly household income is given on this side, and level of income. We first now converted this income into, these are the actual instead of actual values we have used a categorical variables, and then we have used a mode choice. This is the final classes. So, we have got three classes. So, this color is training data, and then we have got testing data. So, we have got a very limited data set of only 20 samples. You can always test this code using some more samples. So, we can use both qualitative data as well as quantitative data in this particular analysis. So, first we will open Python, we will import, we will open the Jupyter notebook, we will import, we will start typing in the code. We will first import the Panda library, then we will import the data set. This is the data set that we are using, and this is and then this data set has been created like the file that you just saw. Then this is the output of the data set, like we can see. This is the car ownership level, this is the income level, this is the final mode, this is the serial number, and so on. And then I want to convert my predictor variable. So, we next need to define which is my predictor variable and what is my response variable. So, that we will set that inputs and targets. So, this is the input and these are the targets. So, targets is set as mode and input is this the other ones. So, we have not taken mode, we have taken the others, and then we can also convert the categorical variables from using this level coder in SCI kit, this scikit learn package, and we can convert this income level into 0 for higher, 1 for lower, 2 for middle. So, this actually helps us this is how we have to do that. We cannot use this as directly. So, once we do the conversion, our data set looks like that. So, car ownership levels, income levels in 1, 2, 3 and so on. Like similarly, we have done in case of logistic model, we also change some categorical variables into dummy variables. So, that is what is being done over here. So, then remove column levels, categorical input from input variables. So, we just done the data conversion. So, once we have ready with the data set, the next is to call the decision tree classifier, and we call it over here tree.decision tree classifier, and we can also give the model fitting criteria. We can introduce many criteria. I am not discussing all of them, only you see that we have the Gini impurity is used for classification. So, this is the classifier, and we can set certain more classifier characteristics of this classification that would be adopted, and then we can generate the model score, and this model score depicts the prediction accuracy, can be increased with more sample size. The higher complexity of the sample, lower is the score. So, we get a model score of 0.6, and these are the predictions. You can see that for sample number 2, car owned is 0, income level is lower, mode choice is auto, and it has predicted correctly auto. So, this is where the prediction is done. So, we model predict for this particular sample, we are getting a prediction of bus, and then for auto we are getting prediction of auto, and so on. So, this is the how we can also get the predictions from decision tree, and we can see that most of them are correctly predicted. So, this one is not correctly predicted, and all the other, and this one is also not correctly predicted. So, this is how we can write a very simple code, and we can develop decision trees using existing algorithms, which are already, the CART algorithm is already inbuilt in. So, we can use that algorithm to generate our decision tree model. Sorry. So, now we will look into random forest decision tree. So, we already discussed what is a random forest decision tree. So, it is an ensemble technique. It has the ability to limit overfitting without substantially increasing error due to bias, and more accurate and stable prediction compared to standard decision trees. If features weren't chosen randomly, base trees in the forest could become very, very highly correlated. So, we randomly select features like income, then it is over here we have used lower and middle, and then over here we could also this is one feature we have taken over here, which is different over here. So, within middle we can split the data into bus and auto directly, and over here we have used middle and lower. Then within lower we have asked the question car owned, but here within higher we have used the question if he owns a car or not, and accordingly we are getting decisions. So, we have randomly chosen the decision criteria. So, this once we have done that, so we develop many trees automatically, it is created, and from there the majority voting for a particular sample would be taken, and the final we get the final result. So, this is how random forest decision tree works. Again, we will go into the Python, and we will go to a Jupyter notebook. So, we import the Panda library, and then we import our the previous data set that we have already used, and then we can use this particular this one hot encoder this to actually do our categorization of the different income categories. So, once we have done with that, then we can define the predictor variables. We can define the predictor variables and the response variables like we have done earlier. So, that is being done over here. So, then we can split the data set into as 80%, like training data is 80%, and then prediction for testing data we have got 20%. So, this is what we have done: X train, Y train, Y test. So, we have split the data into 0.2%. 0.2 is for this the test data. So, automatically 80% is the training data. So, this is how we have set that, and once we have done, we have import the random forest classifier, which is could be seen over here. This is random forest classifier, and then we can again we can set the criteria as Gini. We can also set certain other parameters like the number of estimators, which is 10. This means how many random decision trees would be created. So, this is number 10 decision trees are created, and we can set many other criterias. So, model performance measurement is done, then run with estimator. We can run with different number of estimators. We can see that for 20 estimators model score comes as 0.25, For 10 estimators, model score is 0.75, which is much better than the earlier score of 0.6. And then again for 30 estimators, we have got a model score of 0.25, and for 5 estimators, model score of 0.5. So this seems to be the best number of estimators for this particular data set. Of course, when the data we have a very limited data set. So if we have more data sets, you will see that usually when we increase the number of estimators, the results improve. But again, if we have too many of those, then probably it may not improve much, or it may even degrade. So finally, once we have done this, so we can set this number of estimators, we can change that, and we can actually get different results, and we can then finally print the confusion matrix and see that okay, how many of them are predicted in the right class. So that is how we can measure the model performance. So these are some of the references you can look at. The first set of this code from GitHub, here a more elaborate code is given. You can access that. Here using this code, you can also draw the decision trees in your outcome. So you can see actual structure of the decision tree. Instead of just predicting the final outcome, you can see how the decision structure has been taken, how the decision has been taken. So this is one reference you can follow. So similarly, I have given the references for random forest as well, and these are some of the other references. So to conclude, the multinomial logit model used for mode choice modeling has a closed form mathematical structure and is estimated based on random utility theory, which gives clear interpretable results, but these models are bounded by strict statistical assumptions. So machine learning methods are not limited by these assumptions and are increasingly adopted for modeling travel mode choice, and many studies have found their prediction accuracy to be higher than MNL models, particularly for ensemble techniques like RFDT. Thank you.